Good afternoon and welcome to this webinar with Sunset Learning and Versatile Technology Services. We're happy to have you here today. My name is Eden and I am on the marketing team at Sunset Learning, and with me is Bob Elliott. Bob is a senior consultant for Versatile Technology Services. Working with the company for more than 23 years, he focuses mainly on customers in the service provider industry, and his expertise includes data center builds, systems admin, network admin, device provisioning, virtualization, and training. Thank you, Bob, for being here today and presenting to us, and I'll hand it over to you.
Okay, thanks, Eden, and thanks for the introduction. You guys should see a slide that I'm displaying now. It says DOCSIS Provisioning with Cisco PCP and PNR. So if you guys can't see that, please speak up and let me know. We do training for both products, PNR and PCP, and a lot of the courses are introductory level courses, and it seems like a lot of customers kind of repeat the same thing, and they'll say, some of our folks don't know, what a RDU does or what a DPE does, or what the PNR extension points do. So could you cover that in your class? So it does seem like there's a lot of folks out there that may know some of the components here, but not know how all of them fit together and communicate with each other. So we thought we'd do a 1-hour tech talk on that, just to cover the different components and how they communicate with each other and their roles during device provisioning. So we'll talk about the roles of the PNR servers or the DHCP servers. We'll talk about the roles of the DPEs. They're one of the PCP servers. And we'll talk about what the RDU does when a brand new device boots up on the network, and also when the service level for a customer has to get changed. The RDU comes into play there. So we'll talk about the various server components and what they do to provide provisioning. Some of the stuff we're not going to cover today is versions. So we're not really going to talk about the differences between DOCSIS versions, and the same with PNR and PCP. What I cover today is going to be pretty version neutral. So it doesn't matter if you're running the latest and greatest versions of these apps, or if you're on a version that's a few years old. Everything that I cover in this tech talk should apply to pretty much any version of DOCSIS and any version of the PNR and PCP products. We're not going to cover much on packet cable provisioning, and we're not going to talk about some of the other physical aspects of a cable modem boot up, like ranging. We're going to focus on the DHCP, TFTP, and time of day. So let's just do a quick review of what happens when a cable modem boots up on the network. The first thing it does is it requests an IP address and DHCP options, and it broadcasts out a DHCP discover. And a DHCP server will generally provide an IP address, and it'll also provide DHCP options. So it'll tell the device who the time of day server is, and who the TFTP server is, and what boot file they should download. So after getting an IP address and the device can communicate on the network, it requests the time of day from a time of day server. Once it gets this, the time is synchronized with all the other devices on the network. And it will then request a boot file from a TFTP server. And that'll be generally for DOCSIS cable modems, it's a file with a suffix of CM. And that boot file is going to have some instructions in it. The cable modem is going to execute those instructions, and once it completes, then it will register with the CMTS, and ideally at that point the cable modem is going to be online. So that's just kind of a high-level introduction of what the cable modem requires when it boots up. So now we'll talk about the two products. So the first is PNR, or Prime Network Registrar, and that is Cisco's DHCP or DNS server. It also can be a TFTP server. some other names that it's referred as to maybe CNR or Network Registrar or the DHCP server or the DHCP servers. And typically they are deployed in a failover environment, and you'll have two servers. So they provide both load balancing as well as redundancy. And PNR is required for PCP operations. So with these two products, you can use PNR by itself, but you can't use PCP by itself. You have to use PCP with PNR. And PNR does integrate with PCP and the PCP servers using the PNR extension points. So the other product that we're going to talk about today is PCP, which is Cisco Prime Cable Provisioning. This is an established product. It's been in existence for about 25 years. It's had different names throughout its life. Some other names it's had is BAC or BPR, and you may still see some of these references in some file names or elsewhere within the product. So if you're wondering what BPR is, well, that's just a previous name of the product. And this software is large-scale provisioning and management of device boot up data. So if you're a large MSO and you're managing millions of devices and millions of cable modems, you will need software such as this to manage all of that data. And it is scalable up to millions of CPE devices. I'm not sure the exact limit. Earlier on in the product, it was 30 million. That was, 10 or 15 years ago. It's much higher than that now. I'm not sure the exact limit ability. So some of the differences between the two products: PNR or CNR or DHCP is a DHCP or DNS or TFTP server. The servers communicate directly with client devices, and it provides provisioning services to customer premises equipment. And any company managing a large number of IP addresses would find PNR useful. Some of the customers include, universities and banks, military, and government. And PNR does not require PCP. Any customer managing IP addresses may use PNR, but PCP or Prime Cable Provisioning, that software manages boot files, and some of the server components provide TFTP and time of day functions. And the PCP provides device data to the PNR servers for provisioning. And the target market is any company managing a large number of DOCSIS devices. And PCP does require PNR. It's essentially an extension for PNR, so you can't simply use BAC without using PNR. So now I'll talk about some of the actual server components. So I'll start with the PCP RDU, and that is sort of the authoritative or master server in a PCP environment. Historically, there's only one active RDU per deployment. Some of the bigger MSOs now have multiple RDUs, but there's no mechanism for the RDUs to talk to each other. There's no server that sits above the RDU and provides any management or anything. The RDU is essentially the top level server, and it can process API requests from external applications such as OSS or billing systems. And the RDU builds device configurations for cable modems and CPE devices. It applies policies to determine what type of device it is, what version it is, and what exactly should be in the configuration. It does have extensible plug-in architecture, so the product was made to have applications written to interface with it. And the RDU manages provisioning groups and the other servers. So the RDU is one of the server components. It manages the other server components. So another server component of PCP is a DPE, or a Device Provisioning Engine. And in a deployment, there's typically going to be many DPEs deployed. They typically run on a Linux server, but they can also be containerized. A DPE contains a TFTP and a time of day server, and the DPE persistently caches configs that are supplied by the RDU. So the DPE isn't authoritative. It gets the information from the RDU and caches it. And within each provisioning group, there could be multiple DPEs. If that were the case, the DPEs would all have identical configuration information. They should all have the same information. They provide load balancing and redundancy. And the DPE provides packet cable services for devices. And generally, it's physically co-located with the PNR DHCP servers. So these DPEs are generally regional. You may have, if you got a deployment where you've got one RDU, but you're servicing the nation, you may have a provisioning group in the southeast, and you may have DPEs and CNR servers physically located in the southeast. You may have a separate provisioning group in the northeast, and then you'd likely have a data center up in the northeast, which would have DPE servers and PNR servers. Another type of PCP component server is the KDC, or Key Distribution Center. This type of server is optional. Most of the customers that I have worked with do not use one of these, but I did want to at least bring it up. It does serve as a packet cable security server. It is a CPU intensive server, and it's deployable on a standalone machine, and it does require a Cable Lab certificate chain and a separate license file. So did want to mention that, but that's all we're going to talk about as far as the KDC. And a provisioning group is a regional grouping of customers and devices. Generally, it's a head end, or a city, or a county, and it is serviced by local PNR DHCP servers and DPEs, and it can support up to 4 million devices. And it does maintain its existing provisioning state, even if a connection to the RDU is lost. So ideally, if the RDU goes down, the provisioning group servers such as PNR and the DPE will have enough configuration information to service existing and known clients. And there may be a DNS server, maybe co-resident with the provisioning group servers. And it's the RDU, or the authoritative back server, that manages provisioning groups. So a little background there as far as the servers involved. And this slide here shows a PNR and PCP deployment. So over on the right, we have the regional distribution unit, or the RDU. And generally, there's going to be only one of those. In the bottom center, we do have a provisioning group. Now, keep in mind, in your deployment, there may be many provisioning groups, and each one is going to be associated with a region, or a geographic region. So each provisioning group will generally service a contiguous group of customers or clients. So keep in mind, there's only going to be one RDU, but there's going to be many provisioning groups that are connected to that RDU, and it's the RDU that manages all those servers. Within the provisioning group, there are CPNR, DHCP servers, and DPE, or PCP DPE servers. So they are physically close to customer equipment, and they generally communicate with customer equipment. So Little background there on the servers. Now I'm going to show you a bit of an animation and how the servers get involved. And what I'm going to simulate is self-provisioning. So I'm gonna show you how these servers get involved when a customer is interested in self-provisioning. So essentially, a customer has gone out to a local vendor and they have purchased a cable modem, and they're going to bring it home. They're going to plug it up to the network, to the coax cable. They're going to hook up a PC behind it, and they're going to sign up for service. Now, this particular MSO that we're simulating, they offer self-provisioning. They've got their network set up, so if any unknown devices or unknown cable modems get on their network, they will get an IP address. They will get what's considered an unprovisioned configuration. So they will get very, very limited network access, but it is enough to get them on the network. So initially they're going to be considered unprovisioned. So if you look at this table on the left, the cable modem is going to get a short lease, and it's going to get a private IP address. And the CPE device behind the cable modem is going to get the same. They're going to get a short lease and a private IP address. Now, during this simulation, the customer is going to sign up for service, and they're actually going to get internet service. And at that point, they're going to be considered provisioned. And when that occurs, their cable modem is going to get a long lease and a private IP address. The CPE will get a long lease and a public IP address. So without further ado, we will go through this little animation here, and we're going to simulate self-provisioning. So over on the left, we have this customer premises equipment. There's a cable modem here and a computer hooked up to it. In the center, we have our DHCP server and our DPEs. When I say ours, I mean the ones in our provisioning group. This particular customer may be in Naples, Florida, for example. So they will be using the provisioning group servers, which are located close to them. And in our environment, we also have a single RDU that's over on the right. That's located in our national data center, and it's co-located with our billing and workflow system. So this customer has gone out. They purchased the cable modem. They plug it in for the first time, and it requests an IP address from DHCP. So remember, this is a brand new cable modem. So they broadcast out a DHCP discover. A relay agent gets it, sends it onto the DHCP server, and the DHCP server receives the request, and it asks the DPE for a configuration for this device. So the PNR server sends a request to the DPE and includes the MAC address, and it says, I'd like a configuration for this device. Remember, this is a brand new device. The DPE doesn't know about it. DPE doesn't have any information on it. So the DPE tells the PNR server that it has no configuration for the device. At that point, the PNR server drops the packet. So what you would see in log messages at this point when this happened was on the DPE, we'd see a log message that says, sending no cache configuration for this device. On the PNR server, we see a log message that says the extension pre-client lookup running at extension point pre-client lookup explicitly force the packet to be dropped. So this message is a normal message, the PNR log message. Folks that have worked with these applications may recognize this particular log message. It's a generic log message that gets written to DHCP server logs. And basically, it just means that back did not like this device, or back did not have a configuration for this device, or there was something in back that told the PNR server to drop the packet. It's kind of a generic message. It's not necessarily bad because it's going to get displayed each time a brand new device boots up on the network, because each time a device boots up and there is no configuration for that device, the DPE is going to tell the CNR server there's no configuration for that, and this particular log message is going to be written to the CNR logs. Okay, so after the DPE tells the PNR server that it does not have a device or a configuration for that device, the DHCP server actually sends a request to the RDU to generate a configuration. And it sends along the contents of the DHCP Discover packet that the client sent. And within that DHCP Discover packet is a lot of information about the client. So it's very helpful for the RDU. The RDU uses the contents of that to determine what type of device it is and what version it is. And the RDU would then generate a configuration for that device. And we're going to consider this an unprovisioned configuration because this particular client, they're not a paying subscriber yet, so they can't get fully provisioned on the network. So they get what's considered an unprovisioned configuration, and the RDU generates that configuration and pushes it down to all of the DPEs in the provisioning group. There may be one, there may be two, there may be three, but there could be multiple DPEs in that provisioning group. So DHCP clients are instructed to keep retrying. If they broadcast out a DHCP Discover, but they don't receive any offer back, they are instructed to keep trying. So the cable modem is going to send a retry. So it's going to broadcast out another DHCP Discover. The PNR DHCP server gets that. Again, it asks the DPE for a configuration for this device. And this time the DPE does have one. So the DPE will send a DHCP server configuration for the device. And the cable modem gets what's considered a provisional lease. So it's a provisional lease because they're kind of considered unprovisioned at this point. They're not a paying subscriber yet. So after they get the IP address, they will request time of day. And it's actually the DPE server that provides that. And the cable modem will then request a DOCSIS config and a boot file. And it's actually the DPE the PCP DPE that actually gives it that information in an environment where we're using PCP. So once the cable modem boots up and gets online, then the device behind it, or the PC, goes through the same process. So the PC broadcasts out a DHCP Discover. The PNR server gets it. It asks the DPE for a configuration for the device. This is another new device, so the DPE doesn't have any config for it. The DPE tells us the PNR server that, and the PNR server drops the packet. Then the PNR server sends a request to the RDU. It asks the RDU to generate a configuration for this particular device. And again, the DHCP server forwards the DHCP Discover contents to the RDU, so the RDU has a lot of information about that device. The RDU generates a configuration and pushes it down to all the DPEs in that provisioning group. The device will then retry. Remember, DHCP clients will keep retrying, and This time there is a configuration on the DPE. The DPE provides that to the DHCP server. The DHCP server uses what's in that configuration to generate a packet for that client and offers them an address, and the client gets online. So at this point, they are they're not yet a paying customer, but they have gained access to the network. Now, when they try to launch their browser and they try to go to a web page like facebook.com or something like that, they're going to get redirected. They don't have full internet access. So if they try to browse a web page, they're going to get redirected, and they're going to get directed to a web page that where they can sign up for service. And so at that point, they can specify what level of internet service they want. They would provide payment information and essentially become a paying customer. So when they have completed all of that, the billing system, they would select the level of service that they want, and then the customer is asked to reboot their computer. So they have entered their payment information and everything. So the billing system now connects to the RDU, and it instructs the RDU to regenerate the configuration for their device, because now they are a paying subscriber and they're a paying customer. So now they get a good configuration now. So the billing system makes a request for the RDU to regenerate the configuration with their new class of service, which is provision. The RDU creates the configuration and pushes it down to all the DPEs in the provisioning group. And at this case, there would be a log message on the DPE, and it would indicate that it received an updated configuration for the device from the RDU. Somehow, some system will send a message to the cable modem and to have the cable modem reset or reboot itself. And once it reboots, it then broadcasts out a DHCP discover. The PNR server gets that. It asks the DPE for a configuration for this device. And yes, the DPE does have a configuration. It's a provisioned configuration. So they are given a provisioned lease. The cable modem then requests time of day from the DPE, gets that. Then it requests a DOCSIS config file or a .cm file. And again, it's the DPE that serves as the TFTP server in this environment. The cable modem gets that config file. They execute the instructions. They register with the CMTS and become online. Then the computer behind that cable modem is in the process of rebooting, so that broadcasts out a discover. The CNR server asks the DPE for a configuration for the device. It does have one. It's provisioned. The CPE then gets a public internet routable IP address, and they can now surf the web. From now on, if that cable modem or CPE device reboots, the provisioning group servers get involved. The PNR server and the DPEs get involved, but generally the RDU is not going to be involved from now on. The only time the RDU is going to be involved is if there's another change to service or if there's some kind of change made. But under normal circumstances, if these devices reboot, then they're only going to communicate with the DHCP and the DPE servers. The RDU is not involved in that case. So that's what's going to happen to me after my power comes back on. My cable modem is going to come back on. It's going to request an IP address, and everything's going to be handled locally. The RDU is not going to have to get involved. It'll be the servers that are somewhat local to me here. So keep in mind that it was architected to be a distributed environment. So the servers that the clients need all the time are generally located closer to them. And then the RDU, the authoritative server, that's generally stored in a national data center or the most secure location. So that's a little bit about the server involvement and the communications between the servers when a device boots up. So we covered what the CNR servers do, what the DPEs do, and the role of the RDU during new device provisioning, and the role of the RDU during service level updates. So, you know, when a customer calls up and say, hey, I need faster internet, we saw, you know, we kind of saw how that happens, how they order the faster service, and then the billing system reaches out to the RDU to change their level of service. And then the RDU pushes a new configuration down. And then the next time the device boots up, it gets that new configuration. And we talked about some of the log files. So now you know what to look for, or, you know what some of the normal log messages are. So that's all I really have on the device provisioning. We will take questions. We do offer additional training through Sunset. We usually do a couple tech talks per year. We haven't scheduled the next one yet, but there will be another tech talk on either PNR or PCP sometime this year. We offer a 4-day class for PNR where we cover both DHCP and DNS. We have a PNR PCP combo class, which is a 5-day class. And we offer these classes via remote WebEx delivery or live classes. There is a lot of hands-on in these classes. We like to keep it at least 50% on hands-on and labs, and less than 50% slides and lectures. So we've got a lot of lab servers set up, so you get to dig in and do a lot of configuration if you take any of these classes. So if you are interested in any of these classes, I've got contact information displayed here for both Sandy Alexander from Sunset and myself, Bob Elliott. There is, for additional documentation, mostly for PNR, there's a product landing page. Go to www.cisco.com/go/PNR. And that's a good starting point. Sometimes it's kind of hard to find stuff if you start out on regular old Cisco.com. So this landing page is a good place to start. Okay, that's all I have. I'm going to open it up for any questions. I can, if you have any questions on specific parts of the boot up process, I can go back through the slides and give a little more detail, or any general questions or anything. So I'll open it up to you guys now.
Right, thank you. Hey, that was a great explanation. So the question I had is, when you said you had a single RDU and the only thing that you can do is 4 million devices. So you're saying 4 million for one provisioning group, and we can have multiple provisioning groups that can increase the capacity of that RDU, and how big?
Yes. RDUs can support many provisioning groups. So yes, you know, if each provisioning group has 4 million devices, you know, you could have 20 provisioning groups or so, and have you know, and have 80 million devices or so on an RDU. I'm not sure the exact limitations. I'm not 100% sure it's still 4 million. I know at one point it was 4 million per provisioning group. That may have changed, but that's just kind of a general idea. An RDU will almost always have multiple provisioning groups. The only exception would be a very small cable company that only serviced one region, with a few 100,000 subscribers. They could probably get away with only having one provisioning group. But generally, customers will have multiple provisioning groups on an RDU. Okay, I guess we'll wrap it up. Thank you for attending. Keep an eye out for future tech talks. And if there is any interest in training, please contact Sandy or I, and we can get you set up. We do a lot of customized classes. No two classes are the same. So we generally tailor the courses towards customers' requests. So keep in touch and let us know if you have any Cisco training needs. So thanks again, everybody.